Welcome to Robots in Depth. Today I'm honored to have Tully Foote from OSRF, Open Source Robotics Foundation here. And we're going to talk about making robotics software and hardware available for everyone. And I think your work is just great, because I think having an open source available for everyone platform that we can stand on is essential. Could you tell me how the story got started?
Sure. So a lot of the story of ROS got started at Willow Garage. We wanted to come in and provide for robotics what we saw happen for the web industry. We saw that there was an open source core that a lot of different communities built on top of and could come in and put together their application because all these core components were there and available. And so a lot of this came out of Eric and Keenan were grad students at Stanford, and they were trying to build a robot. And what they encountered was that they wanted to do some research on a robot, and the first thing they had to do was design a robot that would be able to do their research. The next step is they had to build said robot after having designed it. And then by the time they designed it, they got a fully functioning robot. They could remotely operate it to do things like, they have some awesome demo videos of cleaning up a living room, putting cushions back on the sofa, picking toys off the floor. And now they wanted to add software to this to do this autonomously. And they looked around, and there was no framework to do this. There was nothing generally available that they could start as a base and then do their specific application for their robot.
Again, they had to start all over again, doing it from scratch, rather than they already done that. They already done that with designing it and doing the hardware. So I'm thinking the third time they had to start from scratch, they thought there had to be a better idea, right?
Yeah, and so Eric and Keenan brought this to Scott Hassan at Willow Garage and Steve as well. And basically the goal was that we would be able to build up a community and the entire ecosystem and get everybody working on the same page. Because one of the great things about open source is you can put together all this collaboration. And when two people are working in parallel, they don't duplicate each other's work. One person can do part A, one person can do part B, and I can build on top of part A, and you can get twice as far with two people.
Yeah, and also, I mean, we all have our strengths and weaknesses, and if you do what is hard for everyone but easiest the possibility for you, we all do what we are best at, and that just makes it grow that much faster, rather than you having to do things that you're not really suitable for.
Especially, yeah. I mean, the robotics is an industry that brings in expertise from electronics, computer, mechanical, and if you're doing things well, you start bringing in psychology for HRI and all these other things. You need to bring everything together. And so having this open source platform is great, because you can start with a platform and each person who's in their specialty can improve the state of the art for their specialty and not have to re-implement everything that is not their specialty. Yeah. One of the challenges, like as Eric and Keenan were at Stanford, your typical grad student, when they want to do a project, they start off, they read the state of the literature on all topics, even though they want to do research in one particular area. Then they have to go and implement all those topics to a level that's functional enough that they can do the state-of-the-art research in their topic.
Which is just a huge waste of time and very inefficient. And I would also presume that a lot of people and a lot of projects fall by the wayside in this process, because they simply think that what I have to do to even start doing what I want is simply too much. I'm not going to go there. But with a solid foundation, we could really accelerate things. And this is what we've been seeing coming out of Willow Garage and the Open Source Robotics Foundation, that it really does this, huh?
Yeah, and so in addition to putting together ROS and this core platform, we needed to be able to show that you can do collaboration on hardware. And so we put together the PR2 was designed to be this demonstration platform that you can do collaborative robotics on similar platforms in different locations using open source software. And the great thing was, I know that there were people that had publishable research approximately 1 week after receiving their PR2, because they could leverage the tools in the ecosystem that was already there. The robot came, it worked out of the box. All the core functionality was there, and they could just add their little bit of research. In addition, they had all the tools such as the simulation. So before they actually had the robot, they could practice using the robot. in simulation.
Your first platform for hardware was then, of course, the PR2, right? Are you also available in other platforms right now?
Yes, the ROS is available on almost every robot that I know of. Basically, if you're out there and you want to leverage the ROS ecosystem, the first thing you do is you make your robot be able to communicate with ROS. Because once you have the core communications, things like drive forward, turn left, turn right, tilt the head or move the arm, once you get that very basic ROS interface, all of a sudden the entire ROS ecosystem becomes available to you. You can use the motion planning libraries that are integrated. You can use the vision and perception libraries. You can use the higher level logic, which allows you to give a robot this is my task, this is what I want you to do, and these are the subtasks that I want you to do at the same time. All that's available, and all you have to do is make the lower level communications available to your robot.
So that's when somebody has hardware that, and of course adding, if you produce sensors or components in robots, you could also do the same thing there, adapting it to ROS.
Exactly, and we have, in ROS we've developed standard interfaces. So if you have a laser scanner, and there's a lot of algorithms out there for processing laser scanners. But if they all have the same input as we've designed into ROS, then you can plug in any laser scanner. And if a new laser scanner comes along, it gets invented this year, it's better, it's longer range, it does new features, cheaper, any of those things, you can now simply use that same algorithm and plug in the new laser scanner.
Really cool.
All you have to do is have a ROS driver that says, here's the data from the laser, send it out as a ROS message.
So who contributes a lot of work to the project right now?
So we have 200 people contributing release software to the ecosystem. There are many, many more people not releasing things, collaborating in private repositories. One of the great things about ROS is it's completely open.
So we can talk a bit about the license here, as completely open, free as in beer and free as in speech, I guess, right?
So we use the BSD license as our default recommended license. And with that license, it means that, it has 3 clauses, but in general, you can take that software, build it into your product, and there's no requirements except that you keep the license at the top of the header. There are a couple other warranty type things, delivered as is. The great thing about the BSD license is that it is something like 20 lines long.
Very easy.
You can read it. It's very permissive. In general, companies that come and look at it, BSD license is something that they're like, great, we can use that, no problem.
Because it's easy to understand, and it's also not changed. I mean, if it is a BSD license, it's just that. It's been that way for a very long time, right?
Yeah.
So it's something everyone knows. So yeah, this is very accessible. We're on many different robots. Could you mention a few of the robots except the PR2 that runs ROS now?
Sure. So there's the whole line of ClearPath robots that's running ROS. If you look around in the expo hall here at Robo Business, the new go-kart announced by Eugen Robot is running ROS. I've also heard that the Vecna robots are leveraging ROS inside there. And the other thing that's really valuable in ROS is not just what robots are there, but what tools are available. We have developer tools, debugging tools, visualization tools, so that when you put ROS onto a system, you don't just get the communication, but you get tools that build on top and make you more efficient as a developer. As we've designed a lot of our tools to be able to enable plugins, so that if you want to visualize something in a particular way, you can just add a plugin to visualize that exactly what you want to see in the way you want to see it, and add that to the system and extend it yourself. We also encourage, if you do that, people to release it back. But
with the license,
that's again not required.
What are you working on the hardest now? What's your current challenge that you really?
So the big thing that we're working on at OSRF right now is ROS 2.0. We're coming back to the ROS ecosystem. ROS is now coming up on 7 years of operation, and we've learned a lot about it. And what we really want to do is we want to come back, and there are things that we've identified that we would like to do differently, but because there's a ton of ROS users around the world, we don't want to change their API under them, and we want to keep stability so that they can keep doing great research, building great products. And we're working on the next generation of ROS. And for that purposes, we want to make it so that it's even more friendly for people to build products on top of. There are a lot of things when we have commercial users that come in and say, we want this feature, we want this feature, we want this feature, that we are, it's functional, but it's not at the level that the commercial users would like.
So kind of taking the 7-year experience you now have and boiling it down to a new, improved version, so to speak. But at the same time, keeping the old stuff working.
There will be a transition path, and the old and the ROS 1 and the ROS 2 systems will be interoperable. And so you can run a system that's running both parts in each.
Your old stuff could just continue to do whatever it does, and when you need the new feature of ROS 2.0, you could do that in the new system then.
Exactly. And the improvements we're making to the system in terms of reliability, repeatability, we want those to be the selling points, so that when you come along and you say, I want those features, it's worth it for you to rework into the new system. And we're not the old system will keep working for a long time. We're going to make sure to keep supporting that. But as we look forward, we want to there will be improvements to the core infrastructure that will make it more valuable to you as a robot integrator, robot developer, that will sell you on converting.
Can you talk a bit about the ROS Industrial? Is that part of what you do, or?
So ROS Industrial is a separate consortium set up. It's being spearheaded by Southwest Research Institute in San Antonio, Texas. And they're bringing together a group of people a group of companies that want to use ROS in industrial contexts. And it's a way that they can aggregate developer time and resources and figure out, these are things that are common interests for our consortium members. Let's put some effort in, a centralized effort among the consortium members. Each one will contribute a little bit, and then we can go much farther so that this core fundamental piece, which is too big for any individual to sit down and sponsor themselves, but they really do want it. And so now with a consortium, it provides this mechanism that we can push the core capabilities farther, which is in the interest of all the consortium members. But then also they're releasing most of their work open source for the entire ROS community as well.
How's the relationship between you two, these two entities?
We're also a member of the consortium, so we provide input and feedback on their decision-making process as the consortium.
Could you tell me, I mean, you moved this out of Willow Garage because being an open source non-profit foundation made it easier for everyone to sit around the same table. Could you tell me a little bit about the challenge of being a non-profit open source? The
main difference between being a for-profit company and being a non-profit is that we do not have shares, and we have a mission statement to promote open source robotics. And so we are scoped by that mission statement. And that is basically the difference between us and a for-profit company.
What would be the major challenge, you think, running this as a non-profit company? Is it finding funding? Is it operating with other for-profit ventures, or?
Well, we need to be able to find ways that we can interact with the community while maintaining within our mission. We can do almost all the main functionality. We look for grants. We can take contracts. And we can take donations as well. We're always appreciative of donations.
Yeah, of course. I mean, we could just encourage donating of both financial means and, of course, time in improving the what is publicly available for everyone. I mean, Is it money or developer time? If you could wish for something, one of those two, what would be the most significant now, you think?
The most significant we'd like developer time, people to volunteer, join the community. It's much more powerful if we just have a large body of individuals contributing. At the core, we need money to be able to maintain the core of the system and keep things running. But it's much more valuable for you as an individual to come and just contribute, release software, make patches, update documentation. Any of those things can be super valuable to the larger community, and they don't require going through the hurdles of making monetary contributions, etc.
We've seen open source software be very successful in the internet domain with WordPress or GIMP or many, Apache servers and all that stuff. But robotics and hardware have a unique challenge in the safety aspect, because we're out there, we're running around. Some of our robots are very strong and powerful or heavy. You being open source, do you see that as a challenge or a good or bad thing when it comes to the safety and security of our robotic systems?
I think that open source is super valuable to verifying systems. You have a full audit trail of everything that goes in there. you can go through and validate and verify anything. If you're going to pull something in and you want to know that it's going to work right, you want to be able to dig in and go down and look at the source and say, yes, I see what Tully, the developer, did at this point, and I believe that what he's doing is correct. If you find something you think, you can raise a flag, you can point it out, and then it can be discussed in the community.
I am a strong believer in open source software in the fact that in critical, often low-level components, where safety and security is of the utmost essence, because we don't want to hurt people with our robots.
Yes.
Open source, being able to verify everything that goes in, is just essential. And I also think that the long-term aspect of this is going to be available in this shape. I mean, if you stop developing tomorrow, it's still going to be available in this shape or form. And that gives you, if you build your company on this, you know that no dramatic changes is going to occur without you knowing them, and it's always going to be available, and you're going to have a graceful exit then if needed.
Yeah, so avoiding vendor lock-in is really valuable to commercial entities that are considering zooming in and adopting it. I know, for example, the Robonaut on the International Space Station. They went up there and they were using proprietary software to run the Robonaut, but that company decided to stop supporting that product.
As companies sometimes do.
It's in their interest. They can't afford to do it if it's not making money. They have to stop. And so there was not enough big customer base. They decided not to support this. And so now on the International Space Station, the new version of Robonaut, when the legs went up, they got a software upgrade. And they're now using ROS and Orocos to control the Robonaut on the space station.
Because you have that, you can inspect the source code, you have access to the source code, and you know that should ROS for some reason stop supporting it or not add a feature that you're desperate to have in your product, you could maintain it and add that feature yourself if need be.
Exactly, and I know they're using an older release of ROS because NASA has put very good at doing verification. They've run it through a lot of verification, and they know that it's going to be safe for their purposes.
Technology readiness levels you need to go into space are just crazy, right? I mean,
but I believe they have triple redundant safety systems on Robonaut.
You really need that because an accident here on Earth is a big problem, but an accident in space is just hugely expensive and risky for the people up there.
Yeah.
How do you see the future of ROS? I mean, ROS is unique in the fact that when the computer system, when operating systems for computer became available, they were started out as proprietary closed systems.
There have been also proprietary systems. There was Microsoft Robotics Studio. But we really think that being open and building the large community has enabled ROS to grow much beyond what any of these other competitors were doing. And we'd like to have sort of the continuing ecosystem that Linux does for computer OSs.
The difference between Linux and ROS is, of course, that ROS is so early in the history of robotics. I mean, you're already 7 years old, and that's basically the age of this latest boom we've had in robotics. So the event we are at here today is RoboBusiness, and they're 10 years old, and you're 7 years old. So I think that that's going to set the robot industry and business up and community up in a totally different way as opposed to the laptop and smartphone and tablet operating systems that are usually closed. It's just going to be that much more open to startups.
Yeah, so ROS is great at enabling startups. I went to an event in Silicon Valley. There was a pitch fire and 8 different companies were presenting their stuff to VCs. And of the 8 companies, 5 were actually using ROS. And of those 5, I watched the presentations. None of them actually said they were using ROS in their presentation. They're selling their company, presenting to VCs, and they don't actually want... ROS is now just a building block that they're building on top of.
Which was your original goal, I would think, right?
Right, it's great. ROS is enabling them to go farther. And I knew 3 of those companies prior to they're actively in the ROS community. But 2 more of them, I went up and said, hey, how are you doing this? Have you heard of ROS? And they're like, oh yeah, we're using that on the hood. It's great, we love it. And that's the great thing about the ROS community is there's a lot of very public activity on the ROS community, but there's also this hidden activity. There's stealth startups using ROS. There's nothing that we know, we do have absolutely no knowledge that they're using it. but they're using it effectively. They're building companies. They're pitching them to VCs.
It's easy to underestimate what it means to have, if I may say so, the operating system for robotics as an open source project, rather than Linux coming in decades after the fact and trying to provide this freedom and openness that it's doing. This is going to be an enormous long-term impact positive impact on the robotics field, and I think it's great work that you're doing. Do you see ROS being end user exposed?
For end users, we're actually looking at putting together the app type ecosystem, where if you have a robot, there'll be an app ecosystem that you can then pull in, say, I want to run this capability. You search online, you do something. And if you say, I want to run this app, it will actually install everything you need on the robot, configure the robot as you need to use it for that app, and then deploy it.
This usually turns into then a market where you want to sell your app. And if you compare the closed app stores and you compare it with the open web, where you can just download any software to your computer, this would be an open thing too, I would presume, right? So
we're definitely going to be pushing the open end. We're very much open source advocates. Most of us are coming in from the open source computer systems. We know about open, and we really don't want to lock it down. As a nonprofit, our goal is not to monetize, our goal is to facilitate.
As an outsider to the computer industry or onto the robotics industry, it's hard to realize how bad a closed system really is in the long term. And the longer exposure everyone has to proprietary system, the more positive they get to open systems. Very interesting to hear what you're doing at the foundation, and thank you very much for taking the time to do an interview.
Oh, thanks for asking me.
You're welcome. And I hope you enjoyed this episode of Robots in Depth. Please subscribe, share, and visit us on robotsinDepth.com. You can also support us on Patreon. Robots in Depth is supported by Optomica and Robots Up Close. Optomica: rent anything in modular robotics and build whatever you can imagine. Robots Up Close: travel the world and see what's going on in robotics right now, up close and personal. I would also like to especially thank the organizers of the Robo Business Conference for their gracious assistance, without which this interview would not have been possible. I am Per Sjöborg, and I thank you for watching.